and welcome back. And I bet you thought that you would get through one complete lesson without me giving you a math lesson. Well, too bad. So here is a derivation of what would happen if you set the gravitational force. So remember that the force of gravity is going to be equal to m1 m2 divided by r squared, and then we need to put that big G in front of it. And then we also had this force of centripetal, which is going to be equal to mv squared over r. So what we're going to do is set them equal to each other. So the gravity's trying to pull everything in, and then this centripetal force is keeping it going out. And so if we put those two things together and then we do a lot of canceling, we end up with, look at it down there at the bottom, Kepler's third law of motion. So that thing that we came up with that determined the radius that a planet would be from the sun if we knew how long it took to go around and if we knew the mass of the sun. So this is pretty interesting that we can come up with one of Kepler's laws just by setting two of these equations equal to each other. So if you're one of my students, don't worry about it. You see, it says on there, you don't need to know this for the exam. But I just think it's a really good example of using mathematics to predict where the orbit of a planet is going to be located at. So let's do our lesson quiz. How many planets are there in our solar system? Okay, so it's going to be 8, 9 if you want to include Pluto. Jovian planets are composed of what? Okay, now it is true that the Jovian planets do have a core composed of rock and ice, but for the most part, Jovian planets are gas giants. So the correct answer is gas. How many moons are larger than the planet Pluto? The answer is a lot. All right, so if you go back to that one picture that shows the various planets and moons in our solar system, you'll notice that there's actually quite a few of the moons of Jupiter and of Saturn that are actually larger than what Pluto is. And then there's also probably some of those other objects that are further out than Pluto are bigger than Pluto. Number 4. As the gas cloud collapses to form a solar system, it begins to make a disk. Why is this important to the formation of the planets? Because that's where they come from. So the disk eventually turns into the planets. The center of the disk eventually turns into the star. Which of these materials could exist the closest to the sun? So again, if you took a rock and you took a piece of metal and you took some ice and you put them on top of a burner and you start to increase the heat, which is the first one to melt? Well, it's got to be the ice. So now the question is, what about the rock and the metal? So it turns out that metals are going to melt the least. So a rock will melt first, and then the metal will melt. So the ones that are the closest to the sun are going to be the metals. And later, when we talk about Mercury, Mercury has a very large iron core. And that is because it was the one that was the closest to the sun. And so the metal could survive the longest. How did the solar wind alter our solar system? So as soon as that solar wind began to blow, it blew the remaining hydrogen out of the solar system. Okay, and that's it. So in our next lesson, we are going to talk about planetary geology. So we're going to talk about rocks, minerals. We're going to talk about plate tectonics. We're going to talk about the magnetic field of the Earth. And we're also going to talk about what kind of processes carve up the surface of the Earth. So I will see you then. Bye.